Well, tonight was a healthy night. I went to the gym, met my brother, we went for fish and chips, that's potato fries or freedom fries or whatever you want to call them, French fries. And then I met up with a friend called June, who you saw him in the hot spicy noodle video. And June, it's really sort of kind of appropriate because June recently posted a picture while I was in India, which is this church here, and the stained glass is projecting through these lovely patterns of light. And I jokingly mentioned that it looked like a moonflower, and that's what this video is about. It's about an LED moonflower light and hacking it and modifying it to make it completely different-ish. And it's notable that I'm guessing because India has all this sort of light, a lot more sunlight than we have, their windows are quite chunky. And they're obviously just relying on them casting this pattern. It's quite nice. In the UK, our windows tend to have a picture of Jesus snapping a piece of bread, and they tend to be quite complicated. And when we get sunshine, it's kind of rare. It just looks like a pool of vomit lying on the floor. It's just this random mess of colours come through the stained glass windows. So in a sense, these ones are nicer. So I should also mention I drank quite a lot of beer while I was out meeting June, so this video may be less technical than it was originally going to be, but not to worry, it'll be fine. So the donor light is it came off eBay, 10 watt, sound activated or active 64 LED stage lighting DJ lights Moonflower RGBW party light. And it cost £11.60, which is quite cheap. That was including shipping to the Isle of Man from the UK, that's better. And the seller was Hey Wholesale, Hey Wholesale. And they've got so many lists, they've got so many sales and feedback, 21,000 feedback. I'm guessing they're a fairly prominent shipper of Chinese stuff in the UK. But anyway, here is the light itself. And it's based on the classic Moonflower. If I plug this in, actually no, let's plug it into the hoppy meter. Where's the hoppy meter? And see its power, because this is chalk and cheese to the original light it's based on, the classic Moonflower effect. So I'm going to plug this in, and it's going to start running through all sorts of effects. It's got a wee fan in it, which is quite annoying, and it's just shooting a sort of splatter of light, and the power varies up to about, oh, this cable's tangled here. The power varies up to about 8 watts, but you can see it projects a series of points of light, and in this case it chases them backwards and forwards, which is actually quite annoying because you can't stop it chasing them backwards and forwards, and it's quite irritating. It's really close to the bench at the moment, so you're not getting the actual effect on the wall, which is much larger, spaced out dots of light. But very low power, round about, say, on average about 5 or 6 watts. Terrible power factor, it's got a switch mode in it. But that doesn't really matter because it's going to be completely different by the time I've finished it. Probably still have a really terrible power factor. Now, the classic Moonflower effect, you're going to see in here, if I tilt this up, oh, hold on. It'll be a bit out of focus, maybe, but if I shine the torch in here, you can see the panel of LEDs behind this lens. It's quite a nice visual effect, isn't it? Notepad. So the classic Moonflower effect is just one of the classic disco lighting effects, and it was super simple. You had a metal case, often just a square box, and there was a lens mounted in the front, clamped in usually with a metal ring. The lens was clamped in the front, and behind it was a classic tungsten filament lamp, just a little quartz lamp into a socket. And to stop the light going straight through the lens, there was a little metal plate. So if you looked from the outside through that lens, you could see a little metal plate like that with just the pip of the lamp sticking above it, but you couldn't see any light coming directly out. And that went down onto the base. There was usually a big transformer in the back of it to power that, and it was usually a 50 watt lamp in the basic cheapo units. And to fire the light out, at the back there'd be a parabolic reflector. The parabolic reflector filled with bits of mirror. So if this is the parabolic reflector, it would either be filled with discs of mirror, but more commonly square bits of mirror, just basically like an inverted mirror ball, a concave mirror ball with bits of square mirror all over it. And what happened, because those bits of mirror were in the shape of the parabola, the light would bounce off them, and then it would go through the lens. And you'd think because this is blocking the lens to a degree, it filled up a modest space. It would create a visible effect of blocking the light, but it doesn't, because the focal length is such that it can see effectively round that. All parts of the lens would focus onto that bit of mirror. And these mirrors were either all white or they were coloured. And another twist was sometimes there's a motor in the back, a synchronous geared motor. I've got a synchronous geared motor near here. Here is a microwave style synchronous geared motor, mains voltage one. And the circuitry would have audio detecting circuitry. That might have been powered with 12 volts as well. But the synchronous motor doesn't have a specific direction. So every time there's a beat, it would actually rotate that mirror. If there's no music, the mirror would stop. If there's music, the mirror would rotate. And anytime there's a beat, it would just pulse the mirror. It would stop it briefly. And because the synchronous motor doesn't have a specific direction, the parabolic dish would just randomly change direction. It was a fantastic effect. It was super simple, and it just produced tons of, if that was the unit, it would just produce all these beams visibly cutting through the air and highly focused. It was great. It was not efficient. Keep in mind that if this was a sphere with the lamp in the middle and the light coming out all directions, the only bit that came out of was this tiny little bit, the parabolic dish here, and all that was wasted energy. So not efficient, but it didn't have to be. It was in a nightclub, and that 50-watt lamp produced a great visual effect. Roll on the future, and the first really popular LED effects had the same case, the exact same case, same lens, which they've changed now, which is good, but instead of the parabolic reflector, they had a circuit board in the back, and they used 5mm LEDs on it in patterns. And some of the early ones did actually rotate that circuit board. Other ones just chased the pattern. It's easier to chase the pattern, less motors. Some of them had a stepper motor on it and then a sort of ribbon cable going on so they could chase the pattern as well as rotate it. They're a good visual effect, but less reliable because they've got moving parts. And you think, well, a 5mm LED isn't going to be very good. And think of it. So here's a 5mm LED, not at the highest setting. Here's a lens, and it projects a nice sharp dot of light when you point it through that lens. And when you point that at a wall, it may just be a 5mm LED, but it produces a really focused point of light, and it just looks like a bright, sharp dot of light, and it's ultra efficient. And the earliest ones, to compensate for the fact that the lens was really designed to work with a parabola, the LEDs were often kind of stood off from the circuit board and aimed. So they all sort of pointed to the centre point of the lens for maximum efficiency. This unit doesn't appear to have that. It seems to have a flat panel of the LEDs, and it seems to have a much shallower lens, so they've obviously just tweaked everything to fit and make it work. Another option was to use the Fresnel lens. The Fresnel lenses are the lenses that look flat, but they're a series of rings. And usually, like, you know those whole page magnifiers you get? It's a flat plastic sheet that as you hold it near a book, it magnifies the text. That meant they could put a very large lens over the whole front of the light, and then the aiming of the LEDs didn't matter so much because it was just basically a huge lens. It was also very cheap and light to do that. And the circuitry they required for these wasn't very big. They'd just have a wee tiny transformer or laterally a switch mode power supply in the back, and that was it. So cheaper, lighter. The power consumption went from 50 watts or more down to just something like 6 watts. That light is supposedly rated 10 watts. I've not seen it peak at 10 watts yet. Anyway, let's open it. So here's the light. Let's get a screwdriver. Because what I was thinking was, I would like to modify one of these lights to make a stained glass window type projector. And this is just a sort of proof of concept type thing. The focus may be a bit off right at the moment because I was focused down onto the table for maximum clarity of the text and the doodles. But that's okay. Once I get this open, everything should be roughly visible. There's a irksome screw that's not coming out. Okay, so what do we have? We have the switch mode power supply. It's one of these common switch mode power supplies. I'm going to brighten this up at the risk of just over-swamping things, but it's one of those awful power supplies, really common disco lights that's based around a standard switching chip with optical feedback, opto-isolator feedback, and the little regulator chip. And it's got these two sockets in the output, and if you look at them, if you were to put this plug into the other one, it's the same output, but it's the reverse polarity. And it means that if you get that in the wrong position, it will blow up all your electronic circuitry. They do that a lot. It's just a universal power supply with both polarities out in the connector. I like the fact that this diode here, they've got a position for another one, probably in parallel to cut down the heat dissipation of the diode. On the other side of the panel, we've got the mains lead coming in. The mains lead comes in, and the blue, the neutral, is going to the fuse. It's supposed to be a live that goes to the fuse, but we'll turn a blind eye to that. Here is the circuit board with the LEDs. Hold on, let's cut that tie wrap. That is kind of like stopping me from getting things too far apart. So let's unplug this. I'm just going to rip everything out of this because I'm about to modify it. I'm not sure if this is going to work. We'll find out if it doesn't. Here's the LED circuit board, which looks as though it's got... Is it multiplexed in any way? Or is it just... Are these... I think these are just serial driver chips. What is the number on these chips? I'm going to regret this. I'm not going to read the number on the chips. Oh, SN SIM4HC595 by the look of it. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 8 times 8, that is direct driving. These are just serial to parallel converters, and they're just driving the LEDs directly. I don't see any current limiting resistors. I think they're just relying on the internal impedance of the chip. And these LEDs are all sat down hard onto the circuit board. Okay, this circuit board, I'm guessing, it's got the microcontroller, it's got the little op-amp, I'm guessing, on this for the audio circuitry, but could also have been built with the DMX receiver because it's got that crystal for accuracy with the processor. It's got these dip switches if it's designed for the DMX input, the data input, but it doesn't have the rest of the circuitry. And I will say that the number of effects, I don't know why they've got the dip switch here. No instructions came with it, and it's all a bit random what actually happens when you set the dip switches. But that doesn't matter, because I'm just ripping it all out. So out comes that as well. And the power supply come out, and that fan, because the fan will not be needed, because I want this to be quiet. So my idea is to make a new LED panel, and not an animated panel, but just a static panel that you can put your own LEDs in a particular pattern, and it will project it out the front of the unit. So let's get this fan out as well. It's quite a flat lens in this compared to the other ones. I'm guessing that's how they've managed to sort of collimate the light and get it from the flat mounted LEDs. Okay. Right, so the next step here was, because I did this yesterday, I took the original circuit board, I took measurements off it and thought, I'm going to make a new circuit board, and to keep the circuitry simple, there's not going to be a switch mode power supply or anything. It's just going to be powered directly from the mains, and it's going to have a capacitive dropper, because that is just the simplest way to drive these. And the capacitive dropper is out of here. Take a look at the back of this at the same time. The capacitive dropper is just going to be built on the same circuit. Yeah, the diode positions are in parallel, so it can take a second diode there to spread the dissipation a bit. Okay, this is the main, so let's just chop that off. Right, that's it, well modified now. I'll leave the potentiometer on, though I'm not using it, and the microphone just to fill up the holes. Okay. Technically speaking, I should swap the live and neutral connection around. I may do that as well afterwards. But anyway, down goes the plug. And I'll just shove these out the way and show you what I came up with. So let's take the exposure off here and tame it down a wee bit more, because I don't want it to be too glary. Let's put the lid down, in fact. I'll leave this bit up here. It's quite nice that it's got multiple focal positions here. It's got sort of a comb effect that you can slot the circuit board into in various different positions. That's quite a nice, simple mounting arrangement. Okay. So my idea was to use a very simple circuit. It would be the capacitive dropper with a bit of smoothing. So it would start off the mains coming in, it would go through the absolute classic arrangement, I think 330 nanofarad for the array of LEDs, maybe higher. I'll put 2 resistors in series for the discharge resistor because that comes closer to their proper voltage rating. A bridge rectifier, no inrush limiting resistor because the output is going to actually be smoothed by capacitor. And then fundamentally, a couple of resistors to spread dissipation again. And then just a huge chain of LEDs. Literally, I was going to do 64 LEDs, an 8x8 array of LEDs to basically give me a sort of large canvas for doing my sort of electronic doodle on whatever I want to project at the stained glass window. It could even be stained glass window shaped. So that's the circuit. And I initially started by copying the dimensions of the circuit board and just doodling on where I was going to put the capacitor for the capacitive dropper. And then proceeded, you can see I'm really jumping ahead here, to make the transparency for making the circuit board complete with my channel name on it, bigclive.com, which is now sort of creating wire patterns with what's underneath. So then I exposed the circuit board material, and to cut a long story short, here's the circuit board. This was a sort of spontaneous project I did last night. The Patreon supporters probably noticed that I put up a video at a very odd time. It's while I was waiting for this to finish etching, and also I then, at 6 o'clock in the morning, I drilled all the holes out of this. Good timing, that's a good time to do it. Now, I've not tried this in here yet. Is it going to fit, or is it going to need nudged? Or is it going to be too small? It's going to fit, but it's going to need a very fine adjustment with a file, just to basically hone it down to the point it slots in there. Right, so now comes a choice of LED. I have a selection here. I was initially tempted to put in a wide range of colours, but initially, because this is a prototype, and I want to see how well the LEDs focus, I'm actually just going to use blue and red LEDs. And rather than put them in a pattern, I'm going to cover the whole panel. I'm going to put all 64 LEDs in, and I'm just going to do it randomly. So to do that, I'm going to crop the LEDs down. I'm not going to solder them all in right now on the video because that would take a very long time. But I'm going to crop them all down to a very short length. I'm going to place a lot in at a time. And then I'm going to use, where is it? A printed circuit board support jig, which I shall clip this into. And then when I've put the components in, I shall hook this lid on with the foam, and it will press the components down into position, and then I'll turn it over and solder them. This is a Velleman support jig. Unfortunately, I don't think they're available anymore. I've not seen them for a long time. I think this one may have come from either Maplin or Rapid Electronics in the UK, and I've just not seen them since. But it's a great thing. It really works well. This one is just pitted because it's been well used. It's been used to make an awful lot of circuit boards. So right now I'm going to do that. So I'm going to pause momentarily, and I'll be back in a moment with this circuit board hopefully fully populated. And the deed, as they say, is done. So here's the circuit board with the capacitive dropper on it. There's one slight modification I'd want to make, well, a couple actually. The capacitor here is not as high a value as I wanted, so there'll be a very slight shimmer in those LEDs perceivable to you, but not perceivable to the naked eye. Other than that, it's fine. I'd also put a discharge resistor across that, just 1 megohm or something like that. I do have discharge resistor across the dropper capacitor over here though. The LED array is running at about 14 milliamps with a 470 nanofarad capacitor. It could be boosted up. I could use a 506 nanofarad, but that's actually quite bright as it is. It still projects quite a lot of light out the unit. And it only draws about 2.5 watts of power. It's super simple. There's no other circuitry in this. The mains is coming in. I've changed the connections. The live is going to the back of the fuse holder. Note that the live coming in should go to the back of the fuse holder so that when you take the fuse out, the metal ring at the entrance to that fuse holder isn't live. It should be the output so that you can relatively safely put this in. He said make a loud sparking, popping, crackling noise as they try to put it back in. Better still, turn the power off when changing fuses is always a good idea. And apart from that, well, I'll show you what it looks like. In fact, right now, I'm going to point it down at the table. So I'm just going to turn the light off. I'm going to take exposure off, which is going to be horrific. And then I'm going to just try and lift this up as high as I can get it, but I'm not going to be able to show you the full pattern yet. Let's focus down onto that. Is it going to focus down onto that? Oh, no, it's not really going to focus down onto that. Right, okay. I'm going to have to take this somewhere else and show you what it looks like if I can find a clear bit of wall to point this at. So it was quite hard finding a space in the house that was big enough to actually project this. So you can see a light fitting on the ceiling here and an angled ceiling because this is the attic room. And it's quite good. For a short throw of about, say, 18 feet, it spreads about 8 feet wide. Actually, I'd say from 18 feet it's about 6 feet wide. So yeah, 1 in 3 roughly. And I like the colours, but you can see where it's getting close to the edge that the corner LEDs are just starting to get a bit fuzzy because the focal point in them isn't really pointing direct at the lens. The ones in the middle, you can actually see the chips in the middle of the LEDs. But it's a good effect. I like these colours as well. The red and blue actually looks quite stylish. And it provides a nice visual effect. I did try particularly randomness, I did try the diffused LEDs, colour-changing diffused LEDs, just a little panel behind it. It's not very bright because they're diffused. It really needs the focused lens effect. But you still get flat patches of light in a sort of regimented grid projected. And they do, of course, the diffused colour-changing LEDs change colour. If you tried using the focused colour-changing LEDs, because the chip inside, the red, green, blue chips are off to the side and they're separate, you'd actually get separate little clusters of chips, and it might not actually show up too well in some of the edge LEDs where the angle was completely wrong and it pointed at the control chip instead of the little cluster of red, green, blue chips. But this is very nice, and at 2.5 watts it's quite staggering what you actually get, a nice big bright projection. So I'd say that project was a success. My little stained glass window projector does actually kind of work.